Okay, so today we will cover chapter 8, linear inequalities and optimization. We will only do linear inequalities for this video. Optimization would be in the next. So let's look at our learning outcomes. Okay, by the end of this chapter, you should be able to solve linear inequalities and their graph, meaning you should be able to see when you're given an inequality, how do you solve it, how do you move things around and solve the unknown. And also their graphs, meaning how to draw those lines and where to shape. All right. Secondly, you should be able to sketch a few lines and shade the region that you want. An inequality means it's not on the line anymore, it's around the line, it's above or below the line, or it's left or right, it's up or down. All right, so you must be able to sketch. Solve linear optimization problem is what we're going to do in the next video. Okay, so let's look at inequalities. Inequalities are relationships involving more than, less than, more, equals to, less or equals to. Before this, we did equivalent. You did equations. Now you are doing inequality, where it's not equal, where there are constraints involved. All right. A linear equation divides the plane into three distinct sets of points. Like I said just now, above the line, below the line, or on the line. What we did on the line was in chapter 7, where you were needed to draw y equals to mx plus c line. You just draw the line. So we're only talking about the line. Right now, when you're talking about y more equal to, it's above the line. Y lesser or equals to is below the line. All right. So the linear equation graph is the boundary between these regions. A broken line, this is where students always go wrong. When do you draw a broken line and when do you draw a solid line? You draw a broken line when it's more than or less than. You draw a solid line when it is more equal to or less than equal to. Why is it a broken line when it's more than and less than? Because if I'm saying more than, it doesn't include the line. It's above the line. Less than is below the line, doesn't include the line. All right, whereas more equal to, it is the line and above. Less or equals to, it is the line and below. Therefore, you draw a solid line. All right. So let's look at example 1. What integer values of n satisfy the inequality? N is more equals to -2, but n is smaller than 4. Now, what are integers? Integers are whole numbers, cannot be decimals. All right, so how do we find out what does this inequality satisfy? So if n is more equals to -2, then if more equals to -2, then it includes all these numbers, but it is less than 4. So 3, 2, 0, 1 and -1. So these integers that satisfy this is n should be -2, -1, 0, 1, 2, 3. It stops at 3 because n is less than 4. Write down the integers n that satisfies the inequality -5. 2n is more than -5 but less than 6. So you need to divide the whole inequality by 2. You will get -2.5 and 3. So n is more than -2.5 but lesser than 3. So you have -2, -1, 0, 1, 2. You see, n is more than -2.5, but we land up on a whole number because integer is whole numbers. All right. Exercise 8.1 that you see in your manual. List the integers x such that x is more equals to -3 but smaller than 2. So this shouldn't be a problem, right? You just list down the integers. List the values of n where n is an integer such that n plus 4 is more equals to 3 but less than 6. So you must -4 on the left, -4 on the right, and you see what n satisfy. So when you -4 on the left, you will get -1. You -4 on the right, you will get 2. So n is more equals to -1 but less than 2. Therefore, you are left with -1, 0 and 1. Find all the integers values of n that satisfies the inequality. 3n is more equals to -8 but smaller than 6. So you divide the left and right with 3. All right, so you'll be left with -2, -1, 0 and 1. All right, given that x is an integer, write down the greatest value of x for which 2x is less than 7. So x is less than 7 over 2, x is less than 3.5. So the greatest value x can take is 3 because integer must be a whole number. So solving the inequality, this is pretty much similar to earlier. You just move things around. So when you're moving things from left to right, your sign won't flip, all right? I'll show you after this when will your sign flip. So like this, oh, I need to move 3q this side. Yeah, it will move and it'll become positive 3q. Can you see that? But the sign won't change. The 5 will go here and become -5. But the sign will not change, okay? So solving example 3 and 4 is the same, it's just this one is a little different. List the solution that are positive integers. If positive integers, 0 is not included because 0 got no value. Alright? Multiplying or dividing an inequality by a negative number. When you multiply or divide the inequality by a negative value, that is when your sign will flip. Okay, so like I show you here, negative 2 is less than 3. That is true, right? It satisfies the inequality. Negative 2 is really less than 3. Now, if I multiply both sides with negative 1, I multiply the left with negative 1, I multiply the right with negative 1. What will happen? This will become 2. This will become negative 3. See, if the sign don't flip, this statement is not true. 2 is not less than negative 3. Therefore, you will have to flip the inequality. Can you see that? That is why when you multiply or divide, the sign will flip. Alright, to make sure that you satisfy the inequality. Okay, another example, negative 1 is less than 8. Alright, so let's say for an example, I divide both sides with negative 2. So negative 1 over negative 2 is less than 8 over negative 2. This will be half, this will be negative 4. Is this statement true? No, therefore that's why the sign must flip. Alright, so example 2 and 3 involves basically this knowledge where you have a negative, the sign will flip. When you divide any inequality or you times any inequality with negative, you see like this. Negative x is less or equals to 4. So basically you need to bring the negative to the other side, right? You need to multiply this inequality, therefore the sign will flip. Alright, same goes to the 3 examples here. So this really shouldn't be a problem. You should be able to manage. Just make sure your inequality signs are correct. Okay, let's look at graphing a system of inequalities. This is where things get a little bit more difficult. So now graphing y less or equals to 3x minus 1. Basically, you're actually just drawing the line of y equals to 3x minus 1. You just draw that first. So what's your y-intercept? Negative 1, correct? Can you see that? My y-intercept is negative 1. You just need 2 points, your y-intercept and your x-intercept. What is your x-intercept when y is 0? Okay, so 0 equals to 3x minus 1. X will be 1 over 3. So do you see the 1 over 3 here? You plot these 2 points, you draw the line through. Now, how do you know whether do you shade the top or the bottom? If y is more or equals to mx plus c, you shade the top. If y is lesser or equals to mx plus c, then you shade the bottom. So in this case, you shade the bottom. Alright? The next example, you have 3x plus 4y lesser or equals to 12. So if you ask me, you don't really need to change it to this format. Why? It's easier to see this way. You only need the x and y intercept, right? So let's find the y-intercept first. The y-intercept is when x is 0, right? So 3 times 0 is 0, correct? So when x is 0, what is y? 4y equals to 12, y is 3. Do you see that here? Okay, how to find the x-intercept when y is 0? 4 times 0 is 0. So 3x equals to 12, x is 4. Do you see that here? You draw the line through. Now you need to know whether you need to shade the top or the bottom. So if you rearrange it into the y equals to mx plus c line, you will see that it's lesser or equal to. Lesser or equal to, you shade the bottom. You understand? Okay, to be honest, you don't even need to change it to this format. If everything is positive, the sign won't flip. If the y is positive, the sign won't flip. It will still be the same when you change things around. So you don't really need to bring it to this format actually. It's faster this way. Why? Because it's easier for you to find the x and y intercept. It's easier for you to substitute. Oh, x is 0, what is y? Or y is 0, what is x? Because you only need that two to actually sketch the line. So let's look at this system. Now you have more than one. X equals to 2 line. You go to your x-axis. This is 2. You draw a vertical line down. Y equals to 4 line. Y equals to 4. You go to your y-axis. You draw a horizontal line. Now you have x minus y equals to 6. So like I told you just now, when x is 0, y is, you see, we put the 0 at x. Alright? Negative y equals to 6. Y equals to negative 6. Do you see that? That's my y-intercept. When y is 0, what is x? X is 6. So do you see negative 6, 6? The line goes through. Okay? So now you need to know whether you need to shade the top or bottom. So let's do it one by one. X is more or equals to 2. You shade the right. Y is lesser or equals to 4. You shade the bottom. Do you see that? X minus y is lesser or equals to 6. If you don't want to change, you want to use the shortcut I taught you. you just look at the y variable. If the y variable is negative, the sign will flip. If the y variable is positive, the sign won't flip. So this is a trick, but if you cannot understand this trick, then you just change it into the y more equal or less or equals to mx plus c. So you will see that y is more equals to, like I said, the y is negative, the sign will flip. So you shade the top. Okay, so where or does all of it meet? This triangle here. So basically we are going to look at this triangle. All right, and what are corner points? All the intersection points around the shaded region. You need to find 1, 2, 3. These intersection points are called corner points. Okay, let's look at this. X equal to 2 line, you go to the y-axis, you go to the x-axis, 2, x equals to 2. Y equals to 4, you go to your y-axis, 4, y equals to 4. X minus y equals to 6. This is what we drew just now. So this is your region of interest. Your coordinates is 1, 2, 3. Those are your corner points. Do you understand? Okay, so now let's look at the next example. So this is also quite easy actually. So you have x plus 2y less or equals to 12. So if you're going to use the short method that I taught you, you need to find your x and y intercept, right? So when x is 0, what is y? 2y equals to 12, y is 6. Do you see 6 there? When y is 0, x is 12. You draw the line through. The next one, when x is 0, y is negative 6. Do you see negative 6? When y is 0, 3x equals to 6, x is 2. You draw the line. So now you need to know where to shade. So if you're going to use the short method that I taught you, when everything is positive, the sign won't flip. See? The sign won't flip. So less or equals to, you shade the bottom. Oh, my y is negative, so the sign will flip. Do you see that? The sign will flip. So you shade the bottom. If you cannot understand the short trick, then you change it to the y more equals or less or equals to mx plus c. Then you can see where to shade. So the shaded region is like this. It doesn't mean all the time it should be an enclosed region. It can be a region like this, an open region. All right? So same goes to example 3 that you have in your manual now. You have to graph these two. So same thing, when x is 0, y is negative 3. Do you see that? When y is 0, x is 6. Draw the line. When x is 0, y is 4. Do you see that? When y is 0, x is 20. Draw the line. Now, x is more equals to 0, meaning when you see x and y more equals to 0, you do not shade anything in the negative plane. Everything will be in the positive. See, x more than 0, I cannot shade this part because x is more equals to 0. You understand? So this is the region that you are looking for. Now, if you look in your manual on the bottom, there are coordinates. What coordinates are those? Those are the corner points around all the intersection points around the region of interest. So you have 0, 0 here. You have 0, 4. You have 6, 0, and you have this, which is 10, 2. Let's say you can't see it in the graph. Then how do you find this intersection point? You put these two in the calculator, the way I taught you to do simultaneous equation in your calculator. Click your mode 3 times, go to equation, and put it in. You will get x and y immediately. All right, you will get x and y immediately. That will be 10 and 2. So you'll be able to find. So you'll be also able to check your work actually. So you should not go wrong. All right. Same goes to example 4. You do it the way I taught you. If you cannot see, then you can change to y equals to mx plus c and find your x and y intercept. But actually, it's much easier like this. X is 0, y is 3. Do you see that? Y is 3. Y is 0, x is negative 3 over 2, negative 1.5. Draw the line. X is 0, y is 5. Y is 0, x is 5. Draw the line. And then you shade the region. Okay. This is exercise 8.2, question 5 and question 10 basically. So question 5, you will draw all these lines and you will find the region of interest and the corner points. All of these 3 corner points must be the same as my slide. You should be able to get it. Like these two, you just plug it in the calculator, you will get this coordinate. 10, 16 you can get from the calculator. Just plug these 2 equations in and you will get it. All right. Same goes to question 10. You should be able to find all these coordinates. Okay, any 2 lines with the x, these 2, put in the calculator, you can get it. All right, like you want to find this, B, you want to find this. Let's say you can't see it from your graph. X equals to 3, right? Substitute 3 into the equation, you can find what is y. All right, so that's about it for sketching of graphs. You should be able to manage it. If there's anything, then look out for me. All right, so in our next video we will do linear optimization. That will be in our next class. So you have exercise 8.2. You have 10 questions to practice. We will only do 5 in class. The other 5 I will leave you to go home and do it. All right, till then we will meet in the next video.